Thank you, Alan. Good morning, all. So my screen is good there, Alan.
Absolutely good to go.
Brilliant. So good morning. So great opportunity. We're part of this. We're going to focus in on BIM and digital and how it really drives our business. So VisionBuilt is the name of the company. Some of you may be familiar with it. The contents of the presentation is just going to give you an oversight of what VisionBuilt are. Our projects, and then the real detailed part of the presentation is around how digital and BIM really drives our business from design right through to assembly on site. And then just a summary at the end in terms of offsite system build, why use offsite, and the popularity is certainly growing. So a little bit about VisionBuilt. It's an Irish-based and UK-based company. Our facility is in Galway, manufacturing facility, but a lot of our projects are in the UK, which we ship to the UK. We've over 30 years experience in offsite, and we work right through from pre-design, so early contractor involvement, as Joe and Dave mentioned earlier, through to design, manufacture, transport, and installation on site. So a little bit about our team. As Alan mentioned, I'm managing director. I've joined the company in the last 2 months. I spent the last 14 years in main contracting and a particular focus around design. I'm a chartered engineer myself, but some of the notable projects that I've been involved in have been Centre Parks and the Curragh redevelopment. So I suppose our team is based on operations, product development, and in the commercial, that's the management team, and we've 40 people working with us in our Galway office. So then the main concept around it is the integrated approach, and this diagram here, just very simple. When a client has a project, has a design team involved, the earlier involvement the VisionBuilt can have, the better, the more value and more offsite innovation and value engineering that can be brought to it. And it's really that integrated approach between our supply partners, the client's team, and ancillary design certifiers, testers that we partner with, which I'll go through later in the presentation. So I suppose just from my own point of view, a lot of you would be familiar with the Centre Parks holiday park in Longford, and it just gives a little bit of flavour of my own thinking around offsite and the company's thinking around offsite, where offsite is a combination of different aspects, as the guys went through, you know, and various different buildings, whether they're bespoke like the subtropical swimming paradise on the top, right down to housing units, single story, 2-story, etc., right up to 10 stories. So there's a range of different aspects that can be used, and this particular project used different types of aspects, whether it was fully offsite to some assembly on-site, to some localized factories around the project, which benefited still assembly off-site, and the whole concept around how digital drove that to have full coordination before, to make sure there was no clashes, etc. on site. So that project delivered 500 accommodation units in less than 62 weeks, and that was a combination of cold form steel panels, which I'll talk about in this presentation, and also timber frame panels. And then the cross laminate timber was also used for the subtropical swimming paradise, which saved over 400 tonne of structural steel, which was fully coordinated, came from Austria and delivered to site. So a real fascinating project and interesting in terms of off-site. So just to give a flavour of VisionBuilt and the projects we've done, before I get into the system behind that. So this was a hotel travel lodge in the UK. Again, it's a full VisionBuilt structure. So it's a cold form steel panelised structure. It's delivered in 2D and assembled on site. So again, you can see various types of facades that can be used with this technology. Again, it's adaptable for podium levels, as this hotel had large spans on the ground floor, open space. So again, from first floor up, it was a cold form panelized system. This was fantastic projects, number of projects with Dublin City Council. So it was social housing. There was over 150 units developed, driven through BIM. Again, this really got into the detail in terms of coordination of MEP, etc., with the structure, with the architectural models, right down to boarding, number of boards per house in terms of finishes, plaster boarding, etc. So it really was the whole quantification of that gave real robustness to the project. Again, just a Nilford project, 9-story apartments in St. Anne's in London, and finally some other hotels. So it just gives a flavour of the jobs. The real interesting job that we're working on at the minute with Dublin City Council is there's 4 projects, a portfolio of projects, so they range in size, right from 1 to 2-bed social housing right up to 8-story buildings, and this is all done in off-site prefabrication structures by VisionBuilt. So they're actually commenced this week, lifting the first panels in place. So over the coming weeks, you'll see these rise out of the ground, and there'll be some interest and innovation in all of that. So back to the technical side of VisionBuilt, we have an in-house specialized design team, and we also then partner with external companies such as the BRE Evolution, and we're in SAI and Agreement certified and SCI certified, which is for UK, Ireland and Europe, up to 10 stories. We've carried out many different fire tests for different assemblies, which is really the key to offsite. As the guys mentioned, it's all about robustness and quality in design, having the right fire tests, and then quality controlling that right through to the end of the process to ensure that it's built as per design. So again, we're various ISO and in HBC. So the system itself, there's various parts and elements to the system, but as I mentioned before, it's the base product is a cold form steel product. So this is rolled, it's precision engineering, CNC process, rolled in our factory, driven through digital construction using Vertex in the software, which I'll talk about later. But it becomes a panelized system. So we can have various different levels of closed panel systems. Some will be internal, standard stud, load bearing structure. Others will have insulation, wall ties, ancillary brackets for depending on the system, depending on the product specification. Most projects have metal deck flooring, so your standard metal deck flooring. And then there's also structural infill panels, which can be integrated into many different types of structures, whether it be concrete, steel, etc. So in VisionBuilt, we coordinate the hot rolled steel, so any of the larger spans, etc., that needs to be coordinated is also done in VisionBuilt and supplied. So it's really a one-stop shop for the structure of the building. Also, we utilize light flooring, light gauge steel flooring, and this is typically in housing developments or on rooftops, where weight is a big issue. So in terms of the design process itself, you'll be all very familiar, and David and Joe spoke very well about the early involvement and where this is really moving design to as front loaded as possible. So it just gives an idea of, we take the architect's model, we develop our own model, we coordinate that with the structural specifications, M&E model, lift, supplier stairs, civil, substructure, etc. Out of that, we get design freeze. We do our clash detection with various different softwares, including Navisworks. We develop the hot rolled steel, metal decking, and we also supply that. So we end up with a manufacturing model which is to LOD 400. And this is the key point, that every nut and bolt in that model is exactly precisionally engineered and goes to the factory floor. So that's where the key quality control comes into it. And then that needs to be managed, and the assembly verification process on site, getting to LOD 500 is a simple process, because and we'll show how this is tracked right through from project conception right through to completion and handover. So the design process itself, as we said, it's all about that early design process. Once there's an architectural rivet model, and even before that, at pre-planning stage, the thoughts around what types of systems, what types of off-site systems should be used. The panelized system is a versatile system in terms of the shapes of the buildings. They don't look volumetric. They can deal with various different shapes, various different balconies, various different aspects of it. But it's all about getting that coordination done up front. So we developed a panelized rivet model. Out of that, we developed Vertex manufacturing model, and that is sent to our Howick rolling machines on the factory floor. So as I said before, every screw, every item, every assembly is driven through CNC manufacturing. So the assembly on site then is tracked in real time. All the assemblies have barcoded chips which are tracked back into the factory, so we know what's assembled on site, how it's tracked, and that makes the verification process to LOD 500 very, very straightforward. So this is just a short video of the facility in Galway. It just gives a feel for the facility itself and the manufacturing process. As I said, it's a cold form steel panel. They range in gauges of thickness, right from 1 millimeters can go up to 3, even 4 millimeters, which is very uncommon. But typically it's 1.2 to 1.5 millimeters in thickness of cold form steel. The factory is fully ISO quality controlled, so we get external audits and full traceability in product. So the product is rolled from sheet metal. Again, full traceability on sheet metal. It's assembled then in various types of assembly tables, depending on the panel size, depending on the location in the building, etc. So this is a typical wall. As you can see, it's all manufactured, so it's all pre-drilled for screws. The X bracing is installed for lateral stability. And the panels then are in 2D flat packed panels. So again, easy transport to site, particularly when shipping to the UK. You can typically put 2 houses per load per transport, or 2 units per load. These are some of the light gauge steel trusses that's used for housing and rooftops. So as I mentioned, it's fully barcoded. Each of the drawings are tracked right through to the barcode that's placed on the panels itself. So it tracks the amount of usage of HOIC, just making sure capacity in the factory is kept up to the highest level possible. This is showing some of the barcodes that's used for various different panels. So each assembly has its own unique code and its own unique barcode, which is tracked right through to final handover. This is the insulated panel which has been installed. The Abbey slots for taking blockwork wall ties. And again, that's fully coordinated from the models and lifted flat packed onto site. So there's a typical load heading out to the site. So again, this is just a very quick example of a rooftop extension. So you can see it was 64 rooms in 21 days. So pods were dropped in along with that. So the pods again will be fully coordinated with the build, and it was a lightweight flooring that was used for this, and parapets. So how do we get to a really efficient value engineered design? And there's 2 main principles behind it: design for manufacture and a design for assembly. And both needs to be finely balanced to get the optimum output. This slide just shows some of the cost savings that can be done with some actions, such as reducing number of parts. Obviously, if you get to just 1 part, an assembly cost is at 0, so the manufacturing cost is going to be higher to get to that part because it's more complex. Utilizing the standard parts, multifunctioning parts. So this all helps the manufacturing process on the factory floor. Error-proof parts, POCIOCA is a key term in terms of lean construction and lean manufacturing. Design parts for assembly and manufacture, and rivet fasten fixings. What's the right way to fix these assemblies together? What's the tested way? And it's all about assembly testing, whether it's fire, structural integrity, etc. So from the digital side of the business, as I mentioned, digital really drives our business. It's a CNC business, so a CNC manufacturing. So everything that's driven out of our Vertex models is manufactured on the factory floor to that high precision, less than 3 millimeters of accuracy for all our dimensions. So we utilize various different aspects to manage, right from productivity tracking, fabrication, project controls, virtual building and clash detection, component libraries, which again is key to the business going forward, design structure and fabric using Autodesk Rivet, and 5D quantification. We use various Costex Bluebeam as well. So it just gives a feel for how it's driven through the digital environment. So the video probably described better than this slide in terms of what we do, but we have 5 HOIC framing machines. They're highly precision framing machines that take in flat sheet and roll it to various different sections, various different section sizes, depending on the engineering of the project. So our chartered engineers will design the building, design the space in the stud, design the size of stud, the gauge of stud, the bracing requirement, whether it's K bracing or flat bracing, and that will be all then manufactured in our factory and delivered to site. So the installation, we have partners for our installs, so we manage the transport and manage the delivery, but the key point of it is the coordination on site. So it's really down to the key interface is obviously between the substructure and ourselves, and then managing that handover process back to the fit out trades is important. So this gives a feel for the program saving that can be made versus traditional. This was a typical 10-story development that we're working on in terms of early involvement, pre-construction, but it just gives a feel for the 4D construction sequence and how it's assembled. So each floor is panelized. It's metal deck, concrete, and then it just repeats itself. So what you have at the end of the project, at the end of the off-site element of the works, is you have a warm building, which the windows can be installed quickly because the insulation is typically on the panels when lifted in place. And you also have many of your internal walls complete. Some of them will be load-bearing, and there'll be some infill non-load-bearing walls then complete following that. So it gives, it can get up to 40%, typically 30 to 40% program saving. But again, it's all about that early involvement, early design coordination, working really integrated with the design team and the client. So just to sum up, the cold form steel system build and offsite in general, there's been good and bad stories in the offsite construction in the past, and in Ireland and in the UK, but it's really moving to a different place. But each company, whether it's timber, precast, the cold form steel panels, really needs to focus on the quality, and it's quality and design that's really going to drive value in this operation. So the efficient use of material, low waste, easily transported and easily assembled. It's sustainable, so it's made from recycled products, and there's a great strength to weight ratio. Speed of construction, which was demonstrated, and the adaptability. So the use of the concrete or lightweight floors, and particularly the concrete, can give flexibility on the floor plate itself in terms of future use, and it can be all designed in a way that can be adaptable for the future. And the biggest benefit, particularly in the challenges that COVID-19 has brought, is the safety and how we can have a controlled environment in the factory, social distanced, keeping efficiency going with the machines and being spread out in the factory, and then having small numbers on site, because the install on site for this type of system is low numbers. So that's a key driving point for ourselves. So that's the presentation. Thanks all, and thanks Alan.
Thanks Brian, thanks very much. It's great to see such good numbers online, and it's great to see that you're staying online, because the presentations are really of a very high standard, and it's the actually one of the comments I made on the chat box, Brian, was speed of delivery, and particularly savings of time on site. I think you dealt with that well. I mean, that's one of the big advantages, isn't it? That you're actually on and off site much quicker.
It is, it really is. So, and I think it was Joe or David that mentioned about having the substructure, and that works, and particularly if there's demolition or if there's basements or if there's a large substructure package, that both can be done in tandem. So, for example, on the really interesting DCC project that we're working on, we've been manufacturing over the last number of months, and while the substructure works is gone, and we've just started on site this week. So works can happen in tandem, and then it's the rapid build and assembly on site is key.
Yeah. There was an observation there from Ralph Montague again, just talking about, I suppose, the challenges of off-site manufacturing if it's brought in at a later stage. In other words, if you bring OSM right very early in, there are huge advantages. But what about in situations where you traditionally design, traditionally tender, you win the project, and then you start thinking about OSM. That's a real challenge, isn't it?
It is, but we find that a lot of our projects is like that at the minute. In fact, probably 90% of them are like that. So,
right, okay, yeah, interesting.
And it's, I suppose, it's the fact that we're a 2D panelized company rather than a volumetric company. So, if it was full volumetric, it certainly has to be really early days. There's a bit more flexibility, although you'll get better value the earlier you can get. But we find that we can still adapt to most types of buildings, particularly in accommodation space, particularly where they're stacked floor plates, etc. That really suits the system.